And we are again in the Visceral Science Evolution of Stars virtual reality classroom. Now, this is a multiplayer experience where teachers and students come together and they work together to create star systems and learn about how the stars evolve, how the planets around them form, and how the stars eventually die. Now, in this video, we're going to talk about the death of stars, the end of their lives. In this simulation in Visceral Science, we work with 7 types of main sequence stars. We have only main sequence stars. The simulation does not include giants and supergiants. At least it does not, and you cannot create them right away. But you can grow some of the existing stars into giants and supergiants. Now, typically within the school curriculum, kids don't need to learn about different spectral classes, that there are O and B, big blue stars like this cluster that you see to the right of me, and there are other types of main sequence stars like A and F and G and K, stars that usually at the end of their lives grow to red giants and eventually collapse to white dwarfs. And then of course there are red dwarfs. So these stars, they represent 3 different scenarios of how their lives might end. So as I've mentioned to you, these blue stars, that would be a blue star, and that would be a deep white blue star. O and B type of stars, they would be ending their life in a supernova explosion. In the previous videos, we have explained to you how to create these kind of stars. Usually in our simulation, you create them from the nebulas that have a little bit of a glow inside. This glow reminds to the teachers and to the students that they can create a particularly big star out of this nebula. Now, here are all other kind of stars. This is more like a white blue, then white star. Here is an orange, yellow, and eventually a red dwarf. Now, typically there are a lot more red dwarfs in the galaxy, but in this particular instance of a simulation, it actually took me a while to create a red dwarf. I've created all kinds of stars except for red dwarfs, but then we finally got one. So let's go ahead and try to end the lives of some of these stars. So in order to accelerate the life of the star, we need to get into the mini lab. We teleport into the mini lab, then just point your controller at a star and start accelerating its life. So let's go ahead with this one, see what happens. Now, as the star grows, it becomes bigger. It shows how many millions years pass. This is a particularly big star, so it will result in a supernova explosion. So you see, at the end of its life, there is a signature double explosion, and then boom, and a huge shockwave goes all across the galaxy. All other students that are working in other mini labs, they would feel that this team has just exploded its star, it's finished its simulation, and they created, in our case, a neutron star. Nice looking neutron star. So let's go ahead to this bluer star. Maybe this one will produce a black hole. Let's try to explode this one. And once again, I point my controller at this star, I start growing the star, and it goes bigger and bigger and bigger and bigger until eventually this signature double collapse of a star begins. It swallows all the planets around it, and again another big explosion. Boom! The shockwave goes across the galaxy. A very nice, beautiful nebula left over from this explosion, and it creates at the end, what do we get? And this is a black hole. A nice looking black hole. You can even see how my light bends a little bit as I'm pointing at a black hole. So you can notice by the end of the class, the whole galaxy is filled with all kinds of remnants of stars. Now let's go ahead and try to explode smaller level stars. So the second scenario, that was the first scenario where particularly big stars end their lives in a supernova explosion. Now let's go to smaller level stars, like for example these white star. Let's start growing it, and again it grows bigger and bigger, not as big as the supergiant that we have produced. This particular star produces a red giant that starts shedding its layers, losing its mass, and then at some point it collapses into a white dwarf, again leaving a nice looking glowing nebula around this. This time you don't have any shock waves, so other teams, they will not feel like, hey, there was a supernova explosion, but the animation from the red giant collapse is still pretty much visible from every corner of this galaxy. All other stars will likely end their life in a very similar fashion. Now, if we grow this star, this one looks like our sun, actually, a G-type star. Again, similar process, grows to red giant, starts losing layers, and eventually collapses into white dwarf, leaving nice looking nebula. Finally, we have this little fella. Where is he? Where is our red dwarf? Here he is. This is a red dwarf. You can see how everything goes around this star very, 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 very slowly, because of course the mass of the red dwarf is much smaller than of all other stars. Now let's age this star as well, and it just becomes a white dwarf. The red dwarf ends its life as a white dwarf. And of course, these white dwarfs that we have created here, they are glowing, but over time they will cool down, and you will see how they become black dwarfs. How they become black dwarfs and completely cooled down stars. You can see this one is already cooling down a little bit. It's losing a little bit of its light. So this is it. Again, 7 type main sequence stars, 3 main scenarios: supernova explosions that end in black holes or neutron stars. You have medium level stars that end their lives with a red giant collapse and end up as white dwarfs. And finally, you have a red dwarf that ends just as a white dwarf, and eventually it cools down into a black dwarf. Thank you.